Welcome back, everybody. This is 8th grade algebra. Today will be our first of 2 days reviewing systems of equations. So today we're going to talk about what it means to be a solution to an equation or to a system of equations. We're going to talk about what it means when two things must be true at the same time. We're going to compare some restaurant menus. We're going to find solutions to a system of equations graphically. We're going to examine some tricky cases, and then you're going to practice. Tomorrow, we'll be finding the solutions to systems of equations algebraically, using two methods, one, substitution, and two, elimination. And then we'll talk about what it means for something to be a solution in the context of the problem. So let's get started. What is a solution in one variable? What does it mean? Well, if we have an equation like this one, x plus 5 equals 9, you can probably already tell what the one solution is going to be. But you might not have thought about what it might mean for something to not be a solution. X equals 2 is not a solution. And the reason is because when x is equal to 2, the left side of the equation is equal to 7, and the right side is equal to 9. 7 equals 9 is not a true statement. Therefore, x equals 2 is not a solution. X equals 4 is a solution because when x is equal to 4, the left side is 9 and the right side is 9. 9 equals 9 is a true statement. In fact, in this case, x equals 4 is the only solution. You might be thinking, of course it is, I already knew that. But it's important to know that sometimes there's more than one solution. If we have two different variables, x plus y equals 9, I want you to think of a number for x and a number for y that would make this true. Ready? Well, here's something that doesn't make it true. X equals 3 and y equals 2. Because if we have x is 3 and y is 2, then we have 3 plus 2 equals 9. 5 equals 9. That's not true. That's a false statement. So that is not a solution. Can you find a solution to x plus y equals 9? If so, go ahead and enter that solution in the chat. And if you think of another one, you can enter that one too. Now we want to know, what are all of the solutions to x plus y equals 9? You've probably already seen a lot in the chat, maybe yours, maybe somebody else's. In order to do that, I started making a table. And so when x is 0, y is 9. When x is 1, y is 8. And then I plotted all those points here. And so you can see, now I have some of the solutions to x plus y equals 9. But I know that I'm missing some. For example, what about 3.18 and 5.82? When I add those together, I get 9. What about the other two numbers on the screen? When I add those together, I get 9. In fact, I'm just going to start listing a bunch of numbers between 3 and 4 for x and see what y equals. What you'll notice is I get more and more dots that are really close together. And that gives me a hint. In fact, I know that I can never actually list all of the solutions because I can come up with infinitely many ways to have two different numbers add together to equal 9. Not any two numbers, but infinitely many ways to do it. The way that we represent that mathematically is by drawing a line. That line tells you that any point on that line, the x and the y coordinate, when you add them together, are going to make the equation a true statement. That's really powerful because then we don't have to try to list all of the solutions anymore. We can just draw the graph and say that graph represents every single solution to this equation. If it's on the line, yes, it's a solution. If it's not on the line, no, it's not a solution. So now let's digress a little bit. I want to talk to you about Shake Shack. God, I love Shake Shack. If I want to list all the things that are on the Shake Shack menu, I would just look at the menu. If I wanted to list all the things that are on the Five Guys menu, I would list the Five Guys menu. If I wanted to find the solution to what is something that I could get at Shake Shack or at Five Guys, then I would list both menus out, and I would see what are the things that they have in common. Turns out I can get a burger in both places, I can get fries in both places, I can get shakes in both places. Ah, it's so great. That's what we're going to do when solving systems of equations as well. We're going to look at what the two lists of solutions have in common. So for example, if we have two different equations, x plus y equals 9, which we've seen, and 2x plus y equals 12, and we want to find what is something that's a solution to both, that's called a system of equations. Well, let's look at it like we looked at the menu. On the left, we have x plus y equals 9, and we have some of the solutions there. On the right, we have 2x plus y equals 12, and we have some of the solutions there. Can you find anything that is on both lists, that is both on the Shake Shack menu and the Five Guys menu that is a solution to both x plus y equals 9 and 2x plus y equals 12? You might have seen that 3, 6 is on both lists. That means that 3, 6 is a solution to this system of equations because it is a solution to the first equation and a solution to the second equation. Now, we saw earlier that writing out a partial list of solutions is not a great way of going about things. It's not going to give us all of the points. So what we prefer to do is we'd actually prefer to look at the graphs. So here's the graph of x plus y equals 9. There's the graph of 2x plus y equals 12. And we could just look at them and see if there are any points that are on both graphs. Better yet, if we graph them on the same axes, we can see right away that there is a point that is clearly on both. Happens to be 3, 6. X is 3 and y is 6. This might seem very simple, but it gets really powerful really quickly. Here are two equations that you might not know how to find the solution to in any other way. Y equals 3x squared minus 4 and y equals negative the absolute value of 4x plus 16. I don't know how I would start solving these algebraically, but I do know that if I can find any point that is on both graphs, that point is going to represent a solution to this system of equations. So here's the graph of y equals 3x squared minus 4, and here is the graph of y equals negative absolute value of 4x plus 16. Do you see any solutions? Hopefully you saw these two, 2, 8 and negative 2, 8. Now sometimes when you click on a point in Desmos or on any graphing calculator, you might get something very close to the intersection, very close to the point that's on both, but not quite right. And so let's actually check these. We can check these by seeing if x equals 2, y equals 8, and x equals negative 2, y equals 8 are solutions to the first equation and to the second equation. So let's check. Here I'm checking 2, 8 for the first equation. I substitute 2 for x, I simplify and get 3 times 4 minus 4, simplify further and I get y equals 8. So great, 2, 8 is a solution to y equals 3x squared minus 4. Let's see if 2, 8 is a solution to the second equation. Here's the work. 2, 8 is a solution to the second equation as well. So it's a solution to the first, it's on that list of solutions. It's a solution to the second, it's on that list of solutions. It's on both lists, therefore it's a solution to the system of equations. So just to recap, here's what we did. We're finding the solution to a system of equations graphically. That means using graphs. We found all of the solutions to one equation. We found it in the form of graphing it. We found all the solutions to the other equation. We did that by graphing it also. We graphed them on the same set of axes. Because then we could find the points where the two graphs met. That means where the set of all solutions to one equation and the set of all solutions to the other equation, where we found the point that was on both sets. That's the intersections, or where the graphs cross. Just to make sure, we verified algebraically by substituting the x and y of that point of intersection to make sure that we had true statements for both equations. Now I want to talk to you about a couple tricky cases. There are a couple things that might be a little bit different from what you expect. One is when the equations are the same. Two is when the equations have no solutions in common. So the first case, where the two equations are the same, it's like they're trying to trick you. If I show you these two menus, the Five Guys menu on the left and the new restaurant I'm opening, Hawk Burgers, on the right, you might say, wait a second, that's exactly the same menu. They have all the same solutions. That's true. Everything's exactly the same. All of the solutions are the same. Here's a case with two equations where all of the solutions are the same. X plus y plus 1 equals 10, and x plus y equals 9. Do you see why? If not, it's because anything that's a solution to the first will be a solution to the second. How about 1, 8? Yep. How about 2, 7? 2 plus 7 plus 1 is 10. 2 plus 7 is 9. In fact, anything that works for the first is going to work for the second. To look at that graphically, they're exactly the same graph. We can graph them together, and they intersect all over the place. In fact, they're the same line. We would say that this has infinitely many solutions, which does not mean that anything is a solution. 0, 0 is not a solution to either of these, but it means that anything that's a solution to one of them is going to be a solution to the other. And like we saw earlier when there was just one equation, there are infinitely many points that satisfy that equation. The next case we're going to look at is when the equations have no solution. They have nothing in common. The Shake Shack in New Haven is right down the street from Taste of China in New Haven. If anybody ever invites you to Taste of China, you should go. It's incredible. But if you're looking for burgers or fries or milkshakes, you're not going to find them at Taste of China. And if you're looking for squirrel fish or Dao Ban Yu, you're not going to find them at Shake Shack. These two menus have nothing in common. It's a little bit like these two equations, x plus y equals 5 and x plus y equals 9. Anything that's a solution to the first equation, and there are infinitely many x's and y's that make that true, is not going to be a solution to the second equation. You can look at the graphs to see why. Those two graphs are never going to intersect. Now, if you want, you could rewrite these in slope-intercept form and see that they have a slope of -1, and that if the slopes are the same, but they're not the same line, they're never going to cross. So I hope that was a helpful recap. I'm now going to send you into Desmos. You're going to practice for the whole rest of the time today, and I'll see you tomorrow where we'll talk about how to solve some of these systems of equations algebraically. That's it. Thanks. Bye.